All right, so here we are in the second portion, section 7.2 of chapter 7. And in this section, we'll talk about something called effective nuclear charge. So many properties of atoms depend on the electron configuration and how strongly the outer electrons of an atom are attracted to the nucleus. This is described by something called effective nuclear charge, and several pieces describe what this attraction of the electron to the protons ends up occurring to be like. First of all, you just have to know the basic. Electrons are negative. We usually give them a -1 charge. Protons are positive. They're +1. Opposites attract. They want to pull at each other. So how much does it get attracted is what we're going to talk about when we say effective nuclear charge. How much effect does the electron feel by the proton or protons in the nucleus? So here's an electron and a proton, and the amount that it's attracted to the nucleus depends on three things. First of all, this amount of attraction between electrons and protons depends on the number of protons in the nucleus. More protons in the nucleus, well, more attraction for the electrons. Number two, how many electrons are in the way? Because electrons, of course, have negative charge, and negative charge things would repel one another. And so if this electron were in the, say, 6s orbital, and there were all kinds of electrons in here in, say, the 3s or the 1 or the 2s orbital, now this electron is effectively shielded from seeing these protons or being attracted to these protons. And so there's lots of electrons in the way. Also, electrons repel one another, and so these electrons would repel these electrons, and that repulsion would force this electron to experience less attraction by these protons, and therefore experience less effective nuclear charge. Thirdly, as you probably noticed, distance makes a difference. So if the electron is further away from the protons, it's not attracted as strongly. These three pieces right here that describe something called effective nuclear charge are used throughout the entire chapter to describe how different trends or how different reactivities or different ways that atoms act. This describes how they work. So overall, these factors combine into the effective nuclear charge experienced by an electron. It's unique to each electron, and these factors describe how they would be attracted or not very much attracted in an atom. All right? In this chapter, then, we're going to look at about 5 different trends. The 5 different trends are, first of all, atomic size. Second of all, we're going to take a look at ion size. Third of all, we're going to take a look at something called ionization energy, and this is an actual energy like a delta H, like an amount of kilojoules. And we'll look at what's called first ionization energy, where it would be the loss of one electron, a second, a third, a fourth, and we'll look at how those trends are affected by the number of electrons that something would lose. We'll also take a look at the trend of first ionization energies just on the periodic table. Next, we'll look at something called electron affinity. And electron affinity is the opposite of ionization energy. It's an amount of energy, once again in kilojoules, for the addition of an electron, so adding an electron to something. And then lastly, we'll look at just some selected trends that occur in groups or families on the periodic table. So we'll take a look at how do these things affect the reactivity of the alkali metals. How does it affect the reactivity of the halogens? What properties are in the oxygen series, and what causes those? Well, these trends actually cause those. So look forward to having you in the next few videos here as we look deeply into each one of these trends on the periodic table.